I have to admit, I spent way too much time this morning staring at that image you sent over. The one from the Boston Globe, Christmas Eve, 1900.
It creates quite a mood, doesn't it?
It really does. It's this incredibly lavish, full-page illustration where they tried to predict what Boston would look like in the year 2000, and it is just wild.
Mm-hmm.
I mean, they have these massive airships blotting out the sun and moving sidewalks on literally every street corner.
Of course.
But the thing that made me laugh out loud was the dinner situation.
The pneumatic tubes.
Yes. They were completely convinced that by the year 2000, we wouldn't have kitchens. We'd just have these tubes, and roast chickens would be shooting through the city infrastructure directly into our dining rooms.
Whoosh! Dinner is served.
Exactly.
It's a delightful image. And yet, I don't think anyone listening to this had their lunch delivered by a pneumatic tube today.
No, we got Uber Eats instead.
Yeah.
But looking at that image, it feels like a massive failure of imagination. Or maybe an over-imagination.
Well, it's actually a perfect example of the extrapolation trap.
The what trap?
The extrapolation trap. That article failed because they took the coolest, most cutting-edge technology of 1900, Zeppelins and pneumatic tubes.
Right.
And just assumed they would get bigger, faster, and more widespread forever. They just drew a straight line forward.
So they couldn't see the curveball coming.
Exactly. They couldn't foresee the internal combustion engine, let alone the microchip or the internet. They imagined moving sidewalks. They got the automobile.
And this highlights the central problem we're diving into today with the book, The City of Tomorrow, by Carlo Ratti and Matthew Claudel.
The problem is, we are terrible at predicting the future.
So if prediction is basically a parlor trick that usually fails, how are we supposed to plan a city? I mean, we can't just wing it.
And that's the pivot. The authors propose a concept they call futurecraft.
Futurecraft. It sounds a bit like a video game, or maybe a witchcraft sub-discipline.
It's much more practical than that. It's a design philosophy. Instead of getting out a crystal ball and saying, this is exactly what will happen, futurecraft is about saying, what if? It's about generating scenarios. You build prototypes, the authors call them mutations, and you release them into the wild to see if they survive.
So it's like evolution. You throw a bunch of ideas at the wall or at the city and see what sticks.
Precisely. It's about steering the future through design and debate, rather than just guessing. And right now, there's a massive debate happening about what our cities should become.
A real tension between two very different visions.
Exactly.
I felt that tension reading the material. It feels like a battle for the soul of the city. On one side, you have the smart city,
which is a term we hear constantly. Smart city usually implies a top-down approach. Think of a city that is optimized like a machine.
Sensors everywhere, central computers making decisions, maximum efficiency.
Right.
Which sounds good on paper. I mean, who wants a dumb, inefficient city?
True. But the authors argue that the smart city can end up feeling cold. It can feel like you're living inside a computer circuit board. It focuses on the hardware.
Versus the concept the authors are pushing for, which is the sensible city. And that's spelled with an S-E-N-S-E.
Right, the sensible city. It's a play on words. It means the city has sensors, it can sense, but it's also sensible.
Oh.
It focuses on the human side. It asks, how does the digital layer, the bits, interact with the physical layer, the atoms, to actually empower the people living there?
So it's the difference between a city that tells you what to do and a city that gives you the information to do what you want.
That is exactly the discussion. One is about control, the other is about empowerment.
Okay, so today we are going to unpack that tension. We're going to look at why the internet didn't kill the city, what Formula One racing can teach us about urban planning,
and the weird secret life of your trash.
And finally, how we can all become hackers of our own neighborhoods.
It's really a journey from being a passive user of the city to becoming an administrator.
I love that idea. Let's start with the first big myth, though. Because if you were around in the 90s or even the early 2000s, you remember the death of distance.
Oh, the techno-optimism was off the charts. Nicholas Negroponte, Francis Carencross, they all predicted it.
The pitch was so seductive. They said, look, if you have the internet, if you can email and video chat instantly, why would you pay exorbitant rent to live in New York or London?
Right. We were all supposed to move to log cabins in the mountains and work remotely.
It was a very logical prediction, and it turned out to be completely wrong.
Completely.
In fact, the opposite happened. Since the digital revolution really took hold, urbanization has accelerated.
As of 2008, more than half of humanity lives in cities. We are flocking together more than ever.
So why didn't we leave? If I can zoom into a meeting, why do I need to squeeze onto a subway?
Because we are social animals. We crave face-to-face interaction, but also the internet didn't replace physical space. It got woven into it.
Okay.
The sociologist Manuel Castells calls this the space of flows.
Space of flows. That sounds a bit abstract. Help me visualize that.
Sure. Think about a traditional map. You see borders, land masses, static places. That's the space of places.
Got it.
But Castells argues that the real structure of our world now is defined by connections, the flow of money, information, and people between hubs.
There was a project in the notes that visualized this beautifully, the New York Stock Exchange.
Yes, this was a visualization project by the Sensible City Lab. They mapped internet and phone traffic flowing in and out of New York City.
And what did they see?
Well, you don't see New York being disconnected from the physical world. You see these thick, glowing digital arteries connecting New York to London, to Tokyo, to Mumbai.
So the digital traffic actually reinforces the importance of the physical city.
Exactly. The digital world isn't an escape hatch. It's an overlay. We haven't left physical space. We've just become hybrids. The authors use the term cyborg.
Okay, when I hear cyborg, I think of Arnold Schwarzenegger. I don't feel like a Terminator when I'm walking down the street.
You might not look like one, but functionally you are one. Think about how you navigate a city today. If you're in a strange neighborhood, what's the first thing you do?
I pull out my phone and open Google Maps.
Right. And if you need a ride,
Uber or Lyft.
and if you're looking for a date,
Well, I'm happily married, but hypothetically I'd be swiping on an app.
exactly. You are using a digital prosthetic, your smartphone, to navigate and manipulate the physical world.
I'm interacting with the city through a digital layer.
You are a cyborg.
That is a humbling way to put it. I'm staring at a screen to live in the city, not to escape it.
And this interaction, the cyborg navigating the street, is the fundamental unit of the modern city. The question is, how does the city respond to that?
And this brings us to one of the most surprising analogies in the book. Formula One racing.
I know, it seems like it comes out of left field.
I have to say, I did not expect a chapter on car racing in a book about urban planning. But it actually makes a lot of sense.
It's the perfect analogy for the smart city, or the optimized city. If you look at F1 racing in the past, winning was just about the driver and the mechanic.
Gut instinct and grease.
Totally. But about 20, 30 years ago, telemetry changed everything.
Telemetry being the real-time data streaming from the car.
Exactly. The car became a computer on wheels. Thousands of sensors measuring tire pressure, engine temp, fuel load, downforce.
And that data beams to the pit crew instantly.
Where they run analytics, and they tell the driver exactly what to do. Adjust your differential entry settings. Conserve fuel in turn 4. It's a real-time control loop.
Sensors, analytics, actuators. Sense, think, act.
Right, and now cities are trying to do the same thing. That is the smart city dream.
You fill the city with sensors, measuring traffic flow, energy use, water levels.
You feed that into a central system. And you use actuators like traffic lights that change timing automatically to optimize the flow.
Ideally, you get a city that runs like a Ferrari. No traffic jams, no wasted energy.
Ideally. But this is where we get back to that tension we talked about. Let's look at Songdo, South Korea.
This is the poster child for the smart city, right?
It is. It's a city built from scratch at tabula rasa on reclaimed land. It was designed in partnership with Cisco to be the ultimate smart city.
So what's it like?
It has pneumatic trash systems, bringing us back to our 1900 prediction. It has sensors in the pavement. It is incredibly efficient.
But I sense a butt coming.
But the critique, and it's a strong one, is that it feels sterile. It's a computer in open air. When you optimize everything for efficiency, you lose the serendipity.
You lose the messiness, the noise, the life that makes a city a city.
It sounds a bit like living in a hotel. Everything works, but it doesn't feel like home.
Or worse, it feels like an Orwellian machine, where the citizens are just cogs to be managed. If the city's a computer, are we the users, or are we just data points?
And that's the pivot to the sensible city. We want to move from just being optimized to being empowered.
So the sensible city uses that same data, but it directs it back to the citizen. It asks, how can this information help you make a better choice?
Precisely. And speaking of data, the amount we are generating is just mind-boggling. The book calls it big urban data.
It's an exhaust trail we all leave behind. Every time you swipe a credit card, tap onto a bus, or just have your phone in your pocket, you are generating a data point.
And the authors talk about opportunistic sensing.
Which, I have to be honest, sounds a little bit predatory. Opportunistic usually isn't a compliment.
It sounds sketchy, I agree.
Yeah.
But it's actually brilliant. It means taking data that was collected for one boring reason, like billing you for a cell phone call, and using it to understand something amazing about human behavior.
Like the World Cup example.
That's a classic. In 2006, when Italy won the World Cup, researchers looked at cell phone density and call volume in Rome. You could physically see the pulse of the city on the map.
So you could see the game playing out in the data.
You could see the silence, the tension during the penalty kicks. The city basically held its breath.
Wow.
And then the moment they won, there was this explosion of movement and calling. The city lit up. You can see the heartbeat of the city through the data.
That's poetic. But my absolute favorite project in this deep dive, and the one that really made the concept click for me, was Trash Track.
Ah, yes. The Internet of Trash.
Because usually when I throw something away, my mental model is simple. I drop it in the bin, the truck comes, and it vanishes.
It's gone, out of sight, out of mind.
Exactly.
That is the removal chain, and for most of history, it's been invisible. We pay to have the problem taken away. So the Sensible City Lab asked a simple question. What if we could see where it goes?
And they didn't just ask, they actually tagged the trash.
They did. They took thousands of pieces of garbage in Seattle, coffee cups, old electronics, plastic bottles, and attached these little custom GPS tags to them.
And what happened? Did it just go to the landfill down the road?
That's what everyone expected, but the results were shocking. They watched these items travel dizzying distances.
Like how far?
Electronic waste zigzagging across the country, crossing state lines, traveling thousands of miles. A printer cartridge might end up in Florida. A plastic bottle might end up in Mexico. It revealed massive inefficiencies in our logistics.
But here's the futurecraft part that I loved. It wasn't just a map for the government to fix the trucks. It actually changed the people who threw the trash away.
That is the key insight. When the volunteers saw the data, when they saw their specific coffee cup traveling 2,000 miles, they were horrified, and they started recycling more.
The feedback loop changed their behavior.
That's the sensible city in action. It's not a central computer optimizing the trash route. It's citizens seeing the reality and fixing their own habits.
It turns the passive consumer into an active participant.
Right.
Now, I have to play the skeptic here. If we are tracking trash and cell phones and movement, aren't we just building a massive surveillance state? We're talking about Big Brother.
It's the elephant in the room. Privacy is the biggest risk here. But the authors argue that we're actually seeing a shift from Big Brother to something they call Little Sisters.
Little sisters. I'm not sure that makes me feel better. What does it mean?
Big Brother is the state watching you against your will. Little Sisters is us. It's the community watching itself and us voluntarily sharing data because it benefits us.
So, like Waze.
Exactly. You share your location with Waze or Google so you don't get stuck in traffic. You share your life on Instagram. We are trading privacy for value.
So we aren't just victims of the data, we are partners in it.
Ideally. The authors suggest we need a data box concept. Basically, a legal and technical framework where you own your data, you hold the keys,
And you choose when to trade it or sell it, rather than just having it harvested by a corporation without you knowing.
That governance shift is crucial. If we're going to be cyborgs, we need to own our digital limbs.
Exactly. Let's shift gears a bit. We've talked about the invisible data flowing through the city, but what about the city itself? The buildings, the walls, the concrete?
Yes, the book argues that digital tech is going to change architecture just as much as it changes the streets.
This is the concept of responsive architecture.
Right. For a long time, architects have had this dream that buildings should be like living organisms. They should grow, change, and adapt.
Like that movement in Japan in the 60s and 70s called metabolism.
The famous one.
I saw the picture of the Nakagin capsule tower in Tokyo. It's iconic. It looks like a giant stack of washing machines.
It really does. Built in 1972, the idea was incredibly forward-thinking. Those washing machine pods were modular. You could unplug your apartment, lift it off with a crane, and move it to a new building.
That sounds amazing. Why aren't we all living in Lego towers?
Because hardware is hard. In reality, moving concrete and steel, hooking up plumbing and electric, it's incredibly expensive and difficult. Not a single pod in that tower was ever moved or replaced.
So as a dynamic structure, it was a failure.
A total failure.
So if we can't move the concrete, what can we move?
We can move the atmosphere. We can use digital tool sensors and actuators to change how the space feels and functions without moving a single wall.
And there was a beautiful example of this, the digital water pavilion.
It's a stunning project. Imagine a building where the walls are made of falling water, just sheets of droplets. But the nozzles are controlled by a computer. When you walk toward the wall, sensors see you, and the water cuts off in just that specific spot. The wall parts for you, like the Red Sea.
That is so cool. It's architecture that knows you're there.
And while that's an art piece, the practical application is something called local warming. And this directly addresses the energy crisis in our cities.
The quote in the book was, "Man no longer seeks heat. Heat seeks man."
Think about how wasteful our current buildings are. We heat the entire volume of air in an office building, 247, even if there are only 3 people working late.
We are heating empty space.
It's like watering the entire garden when you only have 1 flower.
Right.
So, local warming uses motion tracking and focused infrared beams. It creates a little thermal cloud that follows you specifically.
So if you walk to the window, the heat follows you. If you leave the room, it turns off.
It's like a spotlight, but for warmth. And this connects to the bigger vision of the smart grid. We need to stop thinking of energy or water or waste as these dumb, massive flows.
They need to become like the internet.
Exactly. Packets of resources moving exactly where they are needed, when they are needed. It makes the city incredibly efficient, but in a way that serves the individual, not just the grid.
So we've got responsive buildings, traceable trash, and data flowing everywhere. This makes the city sound like a giant computer. And if there's one thing I know about computers,
They could be hacked.
they can be hacked. And this part of the deep dive actually scared me a little.
It should. This is the double-edged sword. We are entering the era of urban hacking.
And we're not talking about someone stealing your credit card number online.
No, we are talking about cyber-physical threats. If your traffic lights, your subway systems, your water treatment plants, and your gas lines are all networked, a cyber attack becomes a physical attack.
You could paralyze a city without firing a single shot.
It's like the plot of a movie, Die Hard 4 or Sneakers, but it's real.
It is very real.
But the authors, being futurecraft thinkers, also want us to look at the other side of hacking, the positive side.
The white hat hackers.
In a way, they call it open source urbanism. Think about the hacker ethos. It's about taking a system apart, understanding how it works, and improving it.
And citizens can do that to their cities.
Exactly. This is where the apps come in, like the new urban mechanics in Boston. They released an app, one of the first 311 apps, that turned every citizen into a sensor.
So you see a pothole, you snap a picture.
And a phone geotags it and sends it directly to the city work crew. You aren't just complaining to your neighbor, you are helping debug the city infrastructure.
It's bug reporting for pavement.
It is, and it goes even deeper. Look at Ushahidi. This platform started in Kenya during the 2007 post-election violence.
The government media wasn't reporting what was happening.
Right, so they built a platform for citizens to text in reports of violence which were placed on a map in real time. It became a way to see the truth when the official channels were silent.
And it saves lives.
And it is now used globally for disaster relief. This is the ultimate sensible city concept. It brings up the philosopher Henri Lefebvre's idea of the right to the city.
That's a powerful phrase. What does it really mean in this context?
Historically, the city belongs to the rulers, the planners, the admins. Lefebvre argued the city should belong to those who inhabit it.
So open data and these hacking tools give us the right to the city back.
We move from being passive guests, just walking on the sidewalk provided for us, to active participants who help shape the environment.
We get admin rights.
Partial admin rights, at least. And that is a fundamental shift in governance.
So bringing this all together, we started with the pneumatic tubes and the failure of prediction. We've gone through the Formula One data loops, the responsive buildings, the Internet of Trash, and the citizen hackers. What is the big takeaway here?
The synthesis is that the sensible city isn't about the sensors. It's about the feedback loop. It's about the collision of bits and atoms.
Right.
If you just layer technology on top of a city like Songdo, you get a machine. A machine might be efficient, but it has no soul.
But if you use technology to connect people to their environment,
Then you get a living organism. If you use data to show people where their trash goes, they recycle. If you give them tools to report potholes, they fix the street.
the technology shouldn't just run the city. It should connect the citizens to the city.
And that brings us back to futurecraft. The future isn't fixed. It's not a movie we are just waiting to watch.
All these things, local warming, opportunistic sensing, these 311 apps.
They're mutations. They are experiments. Whether they survive, whether they become the norm, Depends on us. It depends on public debate.
We are the ones who decide if we want the thermal cloud following us around or if that's too creepy.
Precisely. We have to engage with the what-if questions now, before the concrete is poured.
So, as you walk through your city today, whether you're navigating with a map app, dodging construction, or just throwing away a coffee cup, I want to leave you with a provocative thought from the deep dive.
If your city is becoming a computer, you have to ask yourself, do you have admin rights or are you just a guest user?
And perhaps more importantly, how smart does your city have to be before you're afraid to live in it?
That is something I'm going to be thinking about for a long time.
Thanks for listening to this deep dive into the city of tomorrow. We'll see you next time.